All right, let's take a look at the last one in section 10.2, number 17. They say to suppose that we have this series, right, infinite series, and we're told the partial sum or the nth term of the sequence of partial sums is this 8 minus 2 divided by n squared. So what are the values of these two sums? You got to be careful to look at what we're doing from n equal 1 to 10 of a sub n and from n equal 5 to 16 of a sub n. And they want exact answers, right, in fraction form. So the first one, right, the summation n equal 1 to 10 of a sub n is a sub 1 plus a sub 2 all the way to a sub 10. Well, this is the 10th term in the sequence of partial sums. Remember, the sequence of partial sums, S1 is the first term in the series we're adding. First term, S sub 2 is the sum of the first two, S sub 3 is the sum of the first three, and so this is the sum of the first 10. But we're given the formula, right? For any value of n, I can compute the partial sum. So all I need to do is plug in n is 10, and I get 8 minus 200ths, which is 8 minus 1/50th, which is 450ths minus 1/50th, or 399/50ths. It's about 7.98, but this is the answer they want in fraction form. Now, the second one, notice, begins at 5, right? So we're going to start with a sub 5 and then go all the way to a sub 16. Well, I want you to note that this is s sub 16, which would be the sum of the first six or the first 16 terms, right? But I'm missing 1, 2, 3, and 4, a sub 1, a sub 2, a sub 3, a sub 4. Well, the sum of the first 4 is just s sub 4. So basically, this is s sub 16, the sum of the first 16, minus the sum of the first 4. And we have a formula for the sequence of partial sums when n is 16. I just plug in 16 here and 4, plug that in, and I get these two expressions. Simplify. Of course, 8 minus 8, that goes away. I've got negative times negative, positive 2 over 4 squared minus 2 over 16 squared. This is 2/16, which is 1/8, and this is 2 divided by 16 squared. I think that's 256. Simplifies down to 1 over 128. Common denominator, simplify. There's your fraction form of that sum. Okay. There's some other questions they ask as well on this one. It says, next is, what is the value of a sub 3? Well, be careful. That's not s sub 3, right? So we're not going to just plug in n equal 3 here. That's s sub 3. S sub 3, right, would be a sub 1 plus a sub 2 plus a sub 3. So how am I going to find a sub 3? Well, notice s sub 2 is a sub 1 plus a sub 2. So do you see how to find a sub 3? It's s sub 3 minus s sub 2. All right, we're going to add the first 3 and then take away the first 2. That will leave a sub 3. So now I can plug into that formula above n equal 3, 8 minus 2/9 here, and then s sub 2, 8 minus 2/4. So simplifying, of course, 8 minus 8 is 0. I get negative times negative. 2/4 are 1/2 minus 2/9. Combine as one fraction, and there is the value of a sub 3. In fact, looking at this pattern, the next question says find a general formula for a sub n. Well, we can do that now because we see a sub 3 is s sub 3 minus s sub 2. So what will a sub 4 be? Well, that's just going to be s sub 4 minus s sub 3. And a sub 5. What's that going to be? S sub 5 minus s sub 4, and so on. And so the general pattern is what? A sub n is what? S sub n minus s sub n minus 1. There's the pattern. So now I know what s sub n is. Here's the formula for s sub n. And then I'm going to replace n with n minus 1 here to get the formula for s sub n minus 1. Now, a little bit of work here to do to get this in a simplified fraction. Of course, 8 minus 8 is 0. Minus a negative, I get 2 over n minus 1 quantity squared, and then minus 2 over n squared. Let's find a common denominator here. I'm going to combine this as one fraction. So basically, I'm going to multiply top and bottom of this one by n squared, and top and bottom of this one by n minus 1 squared. So I get that same common denominator. Excuse me. Now I can combine as 1. 2n squared minus 2 times n minus 1 squared. I'll factor out that 2, so I'm just left with n squared minus n minus 1 squared up top with, or in the parentheses here, times 2. And then notice I can multiply out n minus 1 squared. That's n squared minus 2n plus 1 if I follow that out. But then I've got to multiply by negative 1, so it becomes negative n squared plus 2n minus 1. And then simplify. N squared minus n squared is 0. I just have 2 times the quantity 2n minus 1 over that factored denominator. And that would be a simplified fraction. And you could just double check. For instance, coming back here, we found the value of a sub 3 to be 5/18. If you plug in n equal 3 and simplify, you will get 5/18. Last question, find the sum, n equal 1 to infinity of a sub n. So remember, the series, if it's convergent, then the sequence of partial sums is convergent, meaning that the limit as n goes to infinity of s sub n is a finite number. And in that case, if it is a finite number, that finite number is the sum of the series. So if the series is convergent, then the limit as n goes to infinity of s sub n is a real number. Well, we know what s sub n is, right? What's the limit as n goes to infinity of 8 minus 2 divided by n squared? 2 divided by n squared is going to 0 as n goes to infinity, and we're getting 8, and therefore the series is convergent, and the sum of the series is 8. So the summation n equal 1 to infinity of a sub n is indeed 8. Okay, lots of fun ideas and concepts here. You really need to understand the connection between the a sub n's, the terms in the series that we're adding up, and the s sub n's, right? That is the sequence of partial sums. Okay, I hope this helps.